Now let's take a look at the first example. Okay. This is the homogeneous differential equation. Okay. The second order homogeneous linear differential equation with constant coefficients. So we are going to find the solution of this differential equation. Since it is a homogeneous differential equation, the answer it would be yc. Right? Now, with this one, because this is the second order differential equation, you should be able to find two values of y2. Right? Two values of y1 and y2. Now, in order to find y1 and y2, we've got to assume that y is equal to exponential of mx. And then we do second derivative of y. The first derivative we would get m exponential of mx. And the second derivative of m we would get of y, we would get m squared exponential of mx. Then we plug y1, we plug y, and its differentiative term into our differential equation. We would get m squared exponential of mx minus 3m exponential of mx minus 4 exponential of mx equals 0. And then we take exponential of mx out. As I mentioned before that exponential of mx shouldn't be equal to 0. So that means if you want to make this sentence correct, it is only one way out, that the term inside the parenthesis should be equal to 0. So that means I can write down that m squared minus 3m minus 4 is equal to 0. And this one is called characteristic equation or auxiliary equation. From m squared minus 3m minus 4 is equal to 0. Can we separate this equation into two terms, which is what? Minus 4 and plus 1. So that means m squared minus 3m minus 4 is combining with m minus 4 and m plus 1. So here we can find two values of m, which is m equal to 4 and minus 1. So that means, because you assume that y is equal to exponential of mx, so that means we have two values of m, which is 4 and minus 1. So we have y1 is equal to exponential of 4x, and y2 is equal to exponential of minus x. So these two functions are linearly independent to each other because they are indifferent functions. So that means, you can check Polanski and you would find out that it is not equal to 0. Okay. So that means we can write down yc is equal to c1y1 plus c2y2, which is c1 times exponential of 4x plus c2 times exponential of minus x, and that's the answer. So someone might ask, what if y1 is equal to exponential of minus x and y2 is exponential of 4x? Can you do that? Yes, of course. You can switch. Doesn't matter. Because plus sign has the property of changing the position. Right? You can write this term before this term, or you can write this term after this term. Because c1y1 plus c2y2 is equal to c2y2 plus c1y1, or right? I mean, like, you can switch the term. Any questions? And if you see that this is in the first case because you've got m is the real number and m is unrepeated. 4 and minus 1 is different number. This is the real number. Let's take a look at another example. Okay, this is the third order homogeneous differential equation. So from this one, you would be able to find how many value of m? 3 value of m, right? Because it's the third order. So the way to find the solution of this, you just assume that y is equal to exponential of mx. So you do derivative, first derivative of y, you got m exponential of mx. You do second derivative of y, you would get m squared exponential of mx. You do the third derivative of y, you would get m to the power 3 exponential of mx. And then you plug the value of y and its derivative into the differential equation. So you would get m to the power 3. You have the term which is the same, which is exponential of mx. You take it out. Exponential of mx can't be 0. So you've got to have only one way out, which is the term inside the parentheses is equal to 0, which is called characteristic equation. Now, because you have to find 3 values of m. So the way that you can do it is that you plug the number of 1, minus 1, 0, or 2, minus 2 into here first to see which one can be the solution for this differential equation. So I would say that if m is equal to minus 1, I plug this minus 1 there. I get minus 1 here, minus 4, minus 1 plus 6. Is it equal to 0? Minus 1 minus 4 is minus 5. Minus 5 minus 1 is minus 6. Minus 6 plus 6 equals to 0. So that means one value of m here is m minus 1. So I say that I have m plus 1 here times the rest of the term in here. How can I know the rest of the term in here? I just do the dividing. Okay. What's time m is equal to n to the power 3? n to the power 2, right? If one you do minus 3, you get minus 5 m squared. You do minus, you get 6m. So that means the rest of the term here is m squared minus 5m plus 6 equal to 0. So m squared minus 5m plus 6 is combined with two terms, which is what? m squared minus 5m plus 6 is combining with two terms which are what? M squared minus 5m plus 2 combining with two terms which are m minus 3 and m. So how many values of m we can find now? 3, which are minus 1, 2 and 3. They all unrepeated. So we can write down. So that means you have 3 values of y, which is and they all are linearly independent to each other. So we can say that y3 is equal to c1 y1, c2 y2, which is that's it. Any question?